All right, before I get started on probability, which is what we're going to go over next, I do want to let everyone know I did release a video. It should be on Google Classroom, or at least a link to it. It's actually on YouTube, but the link is on Google Classroom. And it talks about how I'm going to do virtual days. It answers a whole lot of questions that you might have. Some stuff that I'm not going to repeat on this video. But one thing I am going to repeat is I'm going to have what's called office hours, which is just a way of saying time that I'm going to be available for you guys to ask questions. We're going to do that via Zoom, which I think every teacher is going to end up using, or nearly every teacher, I should say, is going to end up using in some way, shape, or form. But I thought I was going to be able to send you a link, but I found out using an iPad, which is what I'm recording this on, I can't do that, or at least I don't know how to do that. So you're going to have to go to zoom.us, and you'll have to enter a 9-digit code for the meeting number and a 6-digit password. I'll provide those. But my office hours are going to be from 10 to noon, Monday through Friday, and from 3 to 4, Monday through Thursday. So there's a lot of time there I'll be available. If you log on, you don't have to stay all 2 hours. I don't know why you would want to. If you only need me for 5 minutes, log on for 5 minutes, log back off, go about your day. If you got another question, log back on, ask, you can jump off, right? That's kind of how they're designed to work. So do watch that first video before you watch this one. These slides should also be shared with you. There are a lot of slides. We're not doing all of them today. I think we're going to do maybe the first 10, and then we'll stop there. We'll end up doing all the slides eventually, just not all of them today. So go watch that first video if you haven't, then come back to this one. Probability. So there's going to be a whole lot of terms that I'm going to end up using today. And it's not like you'll have a quiz over these terms or anything, but you do need to know them. If I say an outcome or sample space, you need to know what that means. So I'm going to do the ever so boring thing and kind of read this paragraph to you. It says an experiment is an activity in which results are observed. So an example of an experiment could be rolling a 6-sided die. We want to see what happens when you roll a 6-sided die. Each observation is called a trial, and each result is called an outcome. So if I pick up that 6-sided die and roll it, I've just completed a trial of our experiment. If it lands on a 6, the outcome was a 6. If I pick up the die, roll it again, I've just done a second trial. If it lands on 2, the outcome was 2. The sample space is the set of all possible outcomes. So it's every possible outcome that can happen when you roll a 6-sided die. And an event is any set of one or more possible outcomes. So that'll be what we find the probability of. So we can try to find the probability of an event where you land on a 6. We can try to find the probability of the event of rolling an even number. We can try to find the probability of the event of rolling a number less than or equal to 2. Stuff like that. So an event is something that we can find the probability of. How do you find the probability? You take the number of desired outcomes and you divide it by the number of possible outcomes. So let's say, for example, we were going to flip a coin. Okay, and the coin has 2 sides, heads or tails. So our sample space for flipping a coin the sample space would be heads or tails. Now these little squiggly fancy brackets here, that's just math notation for identifying what's in between them as a set. All right, if you go back to that first slide, which I'll do right now, it says, it's kind of written over, but the sample space is the set of all possible outcomes, a set. So those squiggly brackets just mean we're using a set. My possible outcomes, landing on heads or landing on tails. So there are 2 possible outcomes. So if I want to find the probability, which we just used with the capital P, of landing on heads, which I'll abbreviate with H, there are 2 possible outcomes. That's the size of my sample space. How many of those are heads? That's what we desire. Just 1 of those. So the probability of landing on heads is 1 out of 2. So let's look at the probability when we roll a 6-sided die, which is your standard die of any game like Monopoly or anything like that. The sample space. Again, the sample space is a set, so we need to use those squiggly brackets. And we want to list every possible outcome. Well, if I roll that die, I could land on 1, I could land on 2, 3, 4, 5, or 6. I can't land on 7. There's only 6 sides, 1 through 6. So the sample space is 1, 2, 3, 4, 5, 6. Make a better look at 5 there. Okay, so there's the entire sample space, every possible outcome. I want to know the probability of rolling a 5. Well, like we said, there are 6 possible outcomes. That will be my denominator, the number of possible outcomes. Now, I'm not going to put 5 up here. I want to know the probability of rolling a 5. Well, there's only 1 5, so there's only 1 desired outcome, so the probability is 1 out of 6. The probability of rolling an odd number, again, there are 6 possible outcomes, but there are 1, 2, 3 odd numbers, so your probability is 3 out of 6, which, yes, you do have to reduce to 1/2. So the probability of rolling an odd number on a 6-sided die is 1 out of 2. So what that means is, theoretically, every time you roll a die, there's a 1 in 6 chance that you land on a 5. Every single time you roll a 6-sided die, there's a 1 out of 2 chance that you land on an odd number. All right, let's say we have a spin wheel. We'll look at something real quick. Okay. So this would be like, I don't know, the game of life. Maybe you guys have been playing that while you've been shut in for the last 2 weeks. I don't have my little spinner here, but if you flick it, it spins around, it lands on a wedge. We want to find the probability of some different events. So it's cut off a little bit over here, but just trust me, these are 8 equal wedges. So we have an equal likelihood of landing on any of them. We want to know the probability that we land on an even number. Well, 2 is even, 4 is even, 6 is even, and 8 is even. So we have the number of desired outcomes is 4 out of 8 possible outcomes, and 4 out of 8 reduces to 1 out of 2. The probability that we land on a blue wedge, well, there are 1, 2, 3 of those. So the number of desired outcomes is 3. Possible outcomes is 8. So the probability is 3 out of 8. All right, what's the probability that we land on a red wedge? There's only 1 of those, this one right here, out of 8 possible outcomes, so that's 1 out of 8. The probability that we land on a prime number. So for those of you who don't remember, a prime number is a number that is divisible by 1 and itself. 1 is not a prime number. You have to be divisible by 2 things to be a prime number. 1 and itself. So 1 does not qualify. It's neither prime or what we call composite. Composite's the other kind of number. 2 is prime. It's only divisible by 1 and 2. 3 is only divisible by 1 and 3. So it is prime. 4 is divisible by 1 and 4, but it's also divisible by 2, so it's composite. 5 is only divisible by 1 and 5, so it is prime. 6 is divisible by a whole lot of things, considering how small it is. 1, 2, 3, and 6. So it's definitely composite. 7 is only divisible by 1 in itself, so it's prime. 8 is divisible by 1, 8, 2, and 4. So it is composite. So we have 4 prime numbers out of 8 possible outcomes, and again, that reduces to 1/2. So the probability that somebody steps up and spins and lands on a prime number is 1 out of 2. All right, now instead of just taking a coin and flipping it one time, we're going to take a coin and flip it twice and see what our results are. So I want to know, what is the sample space? Well, we could land on heads twice in a row, so I'll just call that HH. We could land on tails twice in a row, so I'll call that TT. We could land on heads, then tails, or we could do the opposite of that, land on tails, then heads. So there is every possible outcome. We have 1, 2, 3, 4 different outcomes. So what's the probability that we get heads and heads? That only happens one time out of 4. So the probability is 1 out of 4. Okay, what's the probability of at least 1 tails? At least 1 means 1 or more. So it happens at least once there, there, and there. So that happens 3 times out of 4 possible outcomes. All right, we use something called the fundamental counting principle, and it sounds fancier than what it is, but it essentially tells us how large the sample space is. In other words, the sample size. So we just did an example of a coin being flipped twice, but I'm going to use the fundamental counting principle to find out how big it is. So what you do is pretty simple. You take how many outcomes are possible each time you do something and multiply them together. So if I flip a coin twice, the first time I flip it, I have 2 possible outcomes, heads or tails. The second time I flip the coin, I have 2 possible outcomes, heads or tails. Multiply those together, and we find out the size of our sample space is 4. Now, if you go rewind the video a little bit, you can look back at that last slide and realize that we had heads, heads, tails, tails, heads, tails, and then tails, heads. That's 4 possible outcomes for flipping a coin twice. Well, if we flip a coin 3 times, we have 2 possible outcomes the first time we flip it, times 2 possible outcomes the second time we flip it, times 2 possible outcomes the third time we flip it. 2 times 2 is 4, times 2 more is 8. So if we flip a coin 3 times, we have 8 possible outcomes. So what I want you to do at this point is pause this video and see if you can come up with the sample space for the event of flipping a coin 3 times. For instance, I'll give you the first one. It's going to be heads, heads, heads. Okay? Go ahead and pause and see if you can come up with the rest of them. Okay, hopefully you paused. The other ones would be heads, heads, tails. Heads, tails, heads. tails, heads, heads. And then we have tails, tails, tails. I'm going to run out of room here, I think. Tails, tails, heads. Tails, heads, tails. And then heads, tails, tails. Squeaked it in right there. But we have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes, which is what the fundamental counting principle told us we would have. So flipping a coin 3 times, you could get that amount, you could get that sample size without using the fundamental counting principle. It's not very hard to generate those 8 outcomes. But something like this would be, it would take you forever to come up with this answer. So we have 3 letters are selected for a license plate. How many possible outcomes are there? So for instance, we could have AAA, AAB, AAC, AAD, and then get all the way to AAZ. And now you got to go to ABA, ACA, ADA, all the way to AZA, and then start with ZAA, BAA, CAA, DAA. You can see that this would go on and on and on. If you try to get a list of, list them on a sheet of paper, it would take you forever to come up with the size of that sample space. So what we're going to do instead is use our fundamental counting principle. The first letter, there are 26 choices. For the second letter, there again are 26 choices. And for the third letter, there are 26 choices. Okay? I'm going to bring out the handy dandy calculator here. 26 times 26 times 26. The size of the sample space is 17,576 possible choices. So there are 17,576 different ways to write a combination of 3 letters. So I'm going to ask you to try this one on your own. It says, how many possible locker combinations are there if no number can be used twice in a row? For instance, you cannot have the locker combination of 4, 4, 9. You can't have back-to-back 4s. Now you could have 4, 9, 4. It doesn't say that the 4 can't be repeated. It's just saying it can't be back-to-back. And then I give you a hint here. The numbers on the lockers at school go from 0 to 49. So think about how many numbers that is, and then how you would multiply to figure out how many possible locker combinations there are. So go ahead and pause the video, see if you can figure out what that number would be, and then come back. All right, 0 through 49. That's 50 numbers. Now, for the first number, I don't have any restrictions. It can be any number between 0 and 49. So for the first number of our locker combination, we have 50 choices. I don't have 50 choices for the second number because whatever number I chose here, I can't repeat it. So I'm down to 49 choices. And the same thing for the third number. I can't use this number, so I'm still at 49. I can use whatever number's over here, I just can't use this one. So I'm down to 49 choices. All right, so I'm going to use the calculator again. And 50 times 49 times 49, we have 120,050 possible locker combinations. I guess I should have said in this question that there are 3 numbers in a locker combination, but hopefully you guys didn't need me to tell you that. And the last slide we're going to do, I got one more question to try here on your own. So it says Brooklyn has 4 pairs of shoes. I guess Brooklyn gets a shout out, although I'm going to say hi to Trinity, my favorite brown sister. Brooklyn has 4 pairs of shoes, 7 pairs of jeans, and 10 shirts. If an outfit is 1 pair of shoes, 1 pair of jeans, and 1 shirt, how many possible outfits does Brooklyn have? Okay, go ahead and pause the video and then come back and see if you got your answer correct. Alright, so the first thing she's going to do is pick out a pair of shoes. She has 4 choices. And then she's going to pick out a pair of jeans. She has 7 choices. And then she'll pick out a shirt. She has 10 choices. So 4 times 7 is 28. 28 times 10. She has 280 different outfits if she only has 4 pairs of jeans. 4 pairs of shoes, 7 pairs of jeans, and 10 shirts. Okay, that's where we're going to stop it for now. You do have a Google Doc that has been uploaded for homework. Won't be a whole lot of questions, but go ahead and try to get that done. See if you can take a picture. I have a couple videos in the previous, a couple links to videos in the previous video I did that shows you how to, using an iPhone or an Android, use a scan feature so you can just take a picture of your homework and email it to me. This homework will be due on Friday at 10 a.m. Hope to see you guys during my office hours. It'd be nice to at least tell you hello. Kind of miss some of you guys, all of you guys, to be honest. All right, I'll see you.